This lesson is on section 2.2, titled Comparing and Ordering Rational Numbers. Another great review from 6th grade, math. So let's move right ahead into some examples. Actually, let's go over what the word rational number is. Rational number is a number that can be changed into a fraction or into a decimal easily. So example 1 says, which is larger, 4/5 or 7/10? Now there's 3 different ways we can compare fractions, and I'm going to go through all 3 different ways. You can choose whichever one you want to do. The first way is to compare them using common denominators. So we have the fraction 4/5 and 7/10. Well, I know the least common multiple of least common denominator, I should say, of 4/5 or 7/10 is 10. So I need to change 4/5 into, I can times these both by 2, into 8/10. So now I'm comparing 7/10 into 8/10. And now I can compare them easily because denominators are both 10. And I know 8 out of 10 is larger than 7 out of 10. 8 is bigger than 7, so I know 8/10 is bigger than 7/10. So I know 4/5 is larger. Next example, so I'm still going to be using the numbers 4/5 and 7/10, but we're going to change them into decimals. So in this case, we know our friend, remember our friend's 100, so we always have to, in order to change any numbers into a decimal, we have to get it out of 100. So I can take 4/5, I can multiply these both by 20 to get them 80 out of 100. So that would be 8/10 or 80/100. I can just do that here. And then with 7/10, I know I can just multiply these both by 10 to get 70 out of 100. So that would be 70, I'm sorry, I wrote that wrong. 7/10 or 70/100. Again, you don't even need these here. So I know 80 cents is larger than 70 cents. Again, always compare to money. And I know 8's bigger than 7. So again, 4/5 is larger than 7/10. So you can always change them into decimals if that's what you prefer. The last example is that cross-multiplying method that we talked about. This is kind of a little trick that a lot of students like. So all you have to do with 4/5 and 7/10, you just have to cross-multiply. So I'm going to say 7 times 5 is 35, and I'm just going to put that number right on top of the 7. Again, I'm crossing, putting the number right on top. 4 times 10 is 40. Put the number, again, right on top of the 4. 40 is larger than 35, so 4/5 is larger than 7/10. So again, we have 3 different ways to solve this type of problem. We can either make them turn numbers into common denominators, decimals, or cross-multiplying. And depending on the denominators you're given, you might want to do one way versus the other. In this case, maybe the decimals wasn't the easiest way to do it, but in other cases, when the denominators are a little trickier, it might be easier to turn them into decimals. Next example is we're given a bunch of mixed numbers, and we're asked to order these from least to greatest. So where do we start here? My suggestion is to turn these into decimals. I think this would be the easiest way. Again, you can go back to any of the other ways we talked about with turning them to decimals, turning them to common denominators, or cross-multiplying, but I think this would be the easiest way. So we already have a decimal here. We already have a decimal here, so we can kind of put those aside for now. Let's deal with turning these into decimals. So I know 1/3. Hopefully we have 1/3 memorized by now. If you don't, what you're going to have to do is you're going to have to long divide 3 into 1 because you cannot change 3 into 100 evenly. So we have to long divide. When you long divide, you're going to get 0.3 repeating, or 3/10 repeating. So I can rewrite that as 3 and 3/10. So why don't I do this? Let me rewrite all these numbers we're comparing. So I can turn this into 3 and 3/10 repeating. Now let's look at this one. -3 and 2/5. Well, 2/5, I can easily change that 5 into 100. I just have to multiply both the top and the bottom by 20. So I'm going to get 40/100. So I can rewrite this problem as -3 0.4 or 3.40. We can add a 0 for the sake. And then the last one we don't even have to turn into a decimal because it's already there for us, which is super nice. Now all I have to think about is money. We all know money. Let's take the decimals and think about money that way. So we have, think about 25 cents, 30, we can round that to 33 cents, 40 cents. And this is larger than 25 because it's 0.25 repeating. So it's, you can kind of think it's between 25 and 26 cents. So we know this number here is going to be larger than the negative 3.25. So what we can do is we can say, well, this is, but when thinking about negatives, remember the farther away from zero, the smaller the number gets. So because these are all negatives, we kind of have to think about its opposite way of thinking. So the larger the cents are, kind of the smaller that number is, if that makes sense. So we look at 40 cents is kind of the largest amount of cents. So we know that's going to be the smallest number because that's going to be the farthest away from zero. So the smallest number is going to be negative 3.40. The next one is going to be that negative 3 3/10 repeating. And then we're going to have the negative 3.25 repeating. And the last one's going to be negative 3 25/100ths right there. So we can kind of go back and we can think, okay, well, this one, negative 3.4. So this one was the smallest. So this is number one. Negative 3 3/10 repeating. This is number 2. And then negative 3 25/100ths with that 5 repeating is going to be number 3. And this is my largest. So again, think about changing these into decimals and be super, super careful when you're given that negative sign, because it's kind of think of it the opposite way you're thinking. Here we said that 40 cents was our biggest, so that because it's negative, we got to think it's the farthest away from zero. And that brings us to the end of the lesson. Thanks for watching.